Welcome to another tutorial on MATLAB. In this tutorial series, we are looking into the basic concept related to MATLAB programming. And in this particular video, we will be looking into the concept of logical indexing. In the previous video, we seen mathematical operations related to vectors and also function implementation related to vectors. In case you are interested, please have a look into the same video. In this particular video, we will discuss the logical indexing. So basically, the logical indexing is also a powerful feature that is available for MATLAB programming language. So let's analyze what is basically a logical indexing. So here we have a vector, which is basically called a vector A in our case. And this vector contains 4 elements. First is 35, next is 95 and 72 and 84. And our main objective over here is to extract the value which are greater than 50. So if you are using MATLAB, then it is just one line of code. But if you are using a C language, then in that case you need to implement a for loop to do this comparison between individual elements, and then you will get the outcome whether it is greater than 50 or not. So how basically this logical indexing is working over this case. So if you compare 50 with this entire A vector, then how the comparison will be happening is it will be compared element wise. So 50 will be first compared with 35, and as you know, this is false, so this will be 0 because 35 is not greater than 50. Next is 95. 95 is greater than 50, so that's why it is 1. And then you will have 72 greater than 50, which is basically 1, and 84 greater than 50, which is also 1. Now you got this array which is either 1 or 0, and this is called a logical array. So based on the indexings, like based on the elements, we are getting this logical array. So because of that, it is called a logical index based vector. And now if you use this logical index L, right? So if using this, you can consider like whichever places I have 0, I will not take those elements. Whichever places I have 1, I will take those elements. So here 95 I can take, 72 I can take, and 84 I can take. That is the resultant vector that we are getting, which is the vector B. And now you can see like basically what we did, we just compared this entire vector with a number or with a scalar, and we created this entire logical vector, and using this logical vector we did create our final result. So you can see these elements are greater than 50. What we will do now, we will first implement the first example and then we will go to the second example. So let's go to the MATLAB screen and implement this. So this is the same variable that we have, that is the variable A. Okay, 35, 95, 72 and 84. Now what I will do, I will store it in a variable C so that we can see the outcome of the operation. So A greater than 50. Now what you can see, C is the vector that got created, and you can see there is a tick mark beside the C variable value in the workspace. And you can see this is a logical vector. And how you will distinguish a logical vector from a normal vector? That will be through this tick mark. So this tick mark implies it is either pass or fail, or a tick mark or a cross, which basically represents 1 or 0. That means you are getting a logical variable. That is why this sign is being given as tick mark. And if you see over here, we did also get the same values which we got. Right now, C has this value. So if I double click on C, you will get the outcome of C, like how the C is being organized in a vertical way, like as a column vector. Now what we will do, we will use C to extract all these elements. So now suppose I want to create one more vector, D. I will be using C, not C. So I will be using A, which is the original vector, and with that I will be using my C, which is my logical indexing part. Okay, now if I press enter, so you can see over here that this is the parent vector and this is the logical indexing vector. This sequence you need to follow. What basically is happening over here, wherever it is 0, it is not taking that element, and wherever it is 1, it is taking that element. So if I press enter now, you will have 3 elements inside D, but you will not have 4 elements inside D because one of the elements is not taken because it was 0, right? Because that was logical 0. Now if you see the size for A and D, then A has 4 elements and D has 3 elements. So this is one part which you are able to see, one logical comparison. Now suppose we want to do 2 logical comparisons. So let's jump into the example 2. So let's take the same array which we have, A. Now I want to take the values which are greater than 50 along with that which are smaller than 80. And based on this operation, you can see this is not greater than 50. This is greater than 50 but not smaller than 80. So that's why it is 0. This is smaller than 80 and also greater than 50. So that's why it is 1. And this is not smaller than 80. So that's why it is 0. And it is also greater than 0. It is also greater than 50, but in this case we are not considering it because we are trying to have both the conditions satisfied. So now let's jump into the implementation part of this. So I have the same A vector. Now what I will do, I will do an operation. So I will update my, so in this case, suppose I want to clear 2 variables. So how I can clear specific variables? Clear, okay. I want to clear C and also I want to clear D. So if I press enter, both the variables got deleted in the workspace except A. If I put clear all, it will delete all the variables. But if I put clear and the required variables which I want to delete, then that will be getting deleted. So now let's create the C logical index once more. So let's have A, and now I want to have A greater than 50, right? And also a and. So in this case, I will be using a operation like this, to and I will be also having A smaller than 80. So these two I need to concatenate. So the problem over here is we do not need to. So why the double and is not working over here? Because this is a bitwise operation. So that's why it is not taking double and. Usually if you have a bitwise operation, then in that case you need to use single and the left hand side is having different bits and the right hand side part has different bits. So this has different bit and this is different bit. So that's why we are doing that AND operation using one ampersand sign. And basically you got this logical array, right? So With this, suppose I want to use the same operation which I did previously for D. So to create the D, I use the C index of C, and I use the parent vector, which is A. So now I press enter, I will get the outcome as 72. So this is how you will do this operation for logical indexing. So what is the advantage of using this particular logical indexing operation? It is like you don't need to write specific conditions or specific for loops for the operation. It is within some lines, like within 1 or 2 lines you can implement it, even if you can implement it within 1 line also. So like if you are creating C, right? So how the C is getting created, if A is greater than 50, suppose consider the first example, then this is just a 1 line code and I will get all the elements that are greater than 50. So within 1 line of code, you are able to generate the required amount of data that you need for your implementation. So because of this is a very powerful tool which you can use while doing the programming. And this is a practical implementation also, like how you can do use the logical indexing. You can use multiple layers of logical indexing, like in the second case, like 50 and 80. You can also add some more additional logics after this also, so that you are getting a relevant amount of data that you need. And that is how you can operate logical indexing. Along with that, what you can observe over here is that initial vector size is maybe suppose n, which is basically n in case n in this case is 4. But when you reach to the final one, then in this case n is 3. So there could be possibility that the output vector will not be of the same dimension once you apply this logical indexing, because whenever we are getting 0, that part we are ignoring, and that part is not taken into consideration. Here n is a 4, but after the operation you are getting only 1, n equal to 1. So you are getting n equal to 1. So this is how like the data is getting reduced and you can do the processing more faster, because here the size of the data also getting reduced, right? So that will help you to do better programming in this case. So this is all about the logical indexing, which is a key point which we need to consider while doing the programming part. Yeah, and yeah, in case you are liking the channel, please consider subscribing. In case you have any comment or query, please let us know in the comment section. We will be more than happy to clarify your doubts. Have a great day ahead. Thank you.